Alright folks, so for this video I'm going to start doing quantified logic. Quantified logic is the logic that we are going to be testing you on, so it is very important that you understand how to approach these types of problems and also figure out a way to make the most sense of these translations for yourself. So I'm going to present multiple ways of translating most of these things with the hope that one of them will stick. There are other ways to translate these things, of course. Most of these have many logically equivalent ways of translating. I'm going to tell you the most common ways that these get translated. We're going to do the same thing that we did for basic non-predicate logic translations. First, we look at the sentence and we ask, are there any operators? Are there any negations? Or is there anything we need to figure out? So one thing to note here is that we're saying that there's no Zoroastrians. So that means that we're going to have a negation in here somewhere. And then we can figure out the rest of it. So Zoroastrians is going to be ZX, and then this part is going to be MX. So when we go to translate this, we have to figure out what kind of quantifier do we want. And for quantifiers, we have two options. We have a universal X, which means all X. We have an existential X, which means that there exists an X such that blah blah blah. And it's commonly to see these types of things. So for all of X, if X is an A, then X is a B. That's a pretty common form. For existentials, it's usually something like this. There exists an X such that X is both an A and a B, or a B, etc., etc. So keep these in mind as we go through these translations. So for no Zoroastrians or Muslims, there's two ways to approach this. One way to approach it is with an universal X. We could say that for all of X, if X is a Zoroastrian, then it's not the case that that person is a Muslim. There's an alternative translation. The alternative translation is, it's not the case that there exists an X such that X is both a Zoroastrian and a Muslim. Both of these are appropriate translations for this one. Going on to number two, we can notice that there's no negations, but what we do have is we have an all. So I would say, going back to number one for a second, when we see something like no, you can either see this as a not exist X claim, or you can see it as for some X, and then something down the road is going to have a negation somewhere in it. For all we already know is going to be universal X. So kangaroos and marsupials. Kangaroos are KX, marsupials are MX. So for all of X, if X is a kangaroo, then X is a marsupial. Now there's an alternative translation for this. We could also write this as, it is not the case that there exists an X such that X is both a kangaroo and not a marsupial. For some folks, this might make more sense. For other folks, it won't. Go with the first one. Now let's go to number three. Number three, the thing to notice is we have specific people here. We have Peter Abelard and Jacob Boehme. We also have a not. So is a logician means LX. And then we also know we have an implied LX over here, a negated LX rather. And then Jacob Boehme is little b, Peter Abelard is little a. So if we translate this one, we write Peter Abelard is a logician, LA, because X here is a placeholder, and you substitute in specific variables. But means an and. So and it is not the case that Jacob Boehme is a logician. That would be how to translate this one. Let's go on to 4. Not every marsupial is a kangaroo. So when we see stuff like not every, one of the common ways of translating this is to say not all X. It is not the case that for all of X, blah 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 blah. And then we have marsupial as MX and kangaroo as KX. And there's an implied relational claim here of something being a marsupial, therefore being a kangaroo. So one way of translating this would be to say that it is not the case for all of x that if x is a marsupial, then x is a kangaroo. This is also equivalent to saying that there exists some x out there in the world such that they are both a marsupial and not a kangaroo. These are equivalent statements. 5 looks a little bit more like the type of thing you will see in this class a lot. Nothing is right, so nothing. There's two different ways of translating this. You could translate nothing as not all, or you can translate it as an existential claim, EX, with a negation after it. So let's do it with both. Nothing is right. It's not the case. Or wait for this. Reverse what I just said. I was accidentally doing 6 in my head. So for nothing is right, this could be either X negation something, or it can be not the case that there exists an X such that something. There we go. So for nothing is right. For all of X, X is not right. Or it is not the case that there exists an X such that X is right. The reason that this works is because when you push, quote unquote, a negation through one of the operators, it flips that sign. So if it's a existential, it goes to universal. If it's a universal, it goes to existential. So this would become that. Your rules don't let you do this, but do know that these are equivalent statements. Now let's go on to 6, which I was somehow doing in my head. So not everything is right. So it's not the case for all things, or it would be that there exists an X such that something is not. So not everything is right. It is not the case for all of X that X is right, or there exists some X such that X is not right. These are equivalent statements. Something is right. Something I'm going to go ahead and say is always just going to be an existential X. And then is right. Right is Rx, so there exists an X such that X is right. Then something, EX, is not right. Then we know right is Rx. In other words, there exists an X such that it is not the case that X is right. So here's something to notice. When you look at 6, which says nothing is right, or not everything is right, and 8 that says something is not right, you're going to see that these are actually equivalent statements. Saying that something is not right means that there exists some X such that it is not right, which means that it can't be true that all things are right. I know this language is a little bit obtuse, so I would say let's just do a quick review before I go on to the next video. For quantifiers, we have 2 types of quantifiers. We have universal quantifiers, X's, and we have existential quantifiers, exist X. Universal quantifiers, when they have multiple pieces, tend to have an arrow as an operator. Existentials tend to have not an arrow. They tend to have an and or a wedge, usually an and. In the next video, I'll continue to do quantifier logic, and then we'll continue on into the relational logic eventually.